Good morning students. So today's topic is design of trapezoidal footing. So in the last class we have studied design of rectangular footing. So here also the notations are similar as in the previous one, that is Q1 is the load on the first column, Q2 is the load on the second column, and Q is the total load which is acting at this point at the center of gravity, and L is the length. Okay, and since it is trapezoidal footing, is one side will be B1 and the second side B2. Okay, and X bar and X1 bar, X1, X2 are here, which is same as our rectangular footing. That is, X bar is the distance from the center of the first column to the center of gravity. Okay, and X1 bar is equal to this X1 plus this X bar. Okay, then X2 is the distance between first column, center of the first column, and center of second column, that is X2. Okay, so the steps are somewhat same as our rectangular footing design. So first equate the moment at the point A, that is sigma ma is equal to 0. So from that the equation become Q into this distance X bar is equal to Q2 into this distance X2, that is we are taking moment at this point. So Q into this distance into Q2 into this distance. So we can calculate X bar from this equation. Okay, X bar is equal to Q2 into X2 by Q. Next X1 bar. Here X1 bar is equal to, X1 bar means the distance from left hand side to the centroid, center of gravity. And for trapezoidal footing, the equation for calculating centroid is L by 3 into B1 plus 2B2 divided by B1 plus B2. Okay, that is, this is the equation for trapezoidal footing in order to find the centroid. And for trapezoidal footing, this X1 bar is in between L by 2 and L by 3. Okay, because but in the previous one, that is in the rectangular footing, this X1 bar is equal to L by 2. Okay, that is X1 bar is meeting at the half portion of the rectangular footing, because in the case of rectangular footing, the centroid and the load and the centroid meet at the same point, but here X1 bar is not equal to L by 2 and this X1 bar is in between L by 2 and L by 3. Okay, and in the third step, next step, calculate required area. So required area is equal to total load by QNA. QNA, that is the allowable soil pressure of soil, will be given. So we can calculate area. Okay, and the equation for calculating area in the case of trapezoidal footing is like this. That is, in the case of trapezoid, area is L by 2 into B1 plus B2. Okay, and this X1 bar, equation for X1 bar, that is centroid, I have told, that is L by 3 into B1 plus 2B2 by B1 plus B2. So in this case, that is for design of footing, we have to find the dimension, that is L, B1 and B2. Okay, so in this equation, from this equation, if we solve the equation 1 and 2, we will get B1 and B2. L will be obtained from the previous step. So next we have to calculate B1 and B2. So in order to calculate B1 and B2, equate the equation of area and equation of centroid, and by solving these two equations we will get B1 and B2. Okay, so that is the design. So here we are equating the area in this equation of trapezoidal footing, that is L by 2 into B1 plus B2, and the centroid is equated as L by 3 into B1 plus 2B2 by B1 plus B2, and solve these two equations, we will get B1 and B2. So this is the design procedure for trapezoidal footing. Okay, so we can do one problem. Design a trapezoidal footing for the column in figure. Take allowable soil pressure as 200 kilonewton per meter square. So the figure of this footing is given like that, that is Q1 is equal to 2000 kilonewton, Q2 1500 kilonewton, and dimension of column is 0.5 by 0.5 meter, here also 0.5 by 0.5 meter, and the distance between two columns, that is 6 meter. Okay, so you also draw the plan like this, and mark the notations like X1, X2, X1 bar, then X bar. x1 bar and x bar. And first step, equate moment at the point A as 0, that is sigma ma is equal to 0. So q into x bar is equal to q2 into x2. So x bar will be obtained as 2.57. Okay, then x1 bar, what is x1 bar? x1 bar is equal to x1 plus x bar. x1 means distance from the center of this footing from the left hand edge, that is half of this column dimension will be the x1, that is 0.5 by 2 x1 plus x bar 2.57, that is x1 bar is equal to 2.82 meter. Okay, that is x1 bar. Okay, and L minimum, here what is the minimum length? That is center to center distance is 6 meter and plus this 0.5 by 2 plus 0.5 by 2, that is 6.5 meter is the minimum length. Okay, and next, so next we have to check whether this x1 bar is in between L by 2 and L by 3. Okay, that is L by 2, L minimum is obtained as 6.5, so L by 2 is 3.25, L by 3 is 2.17, and our calculated x1 bar, that is 2.83, is between these two values, so trapezoidal footing is okay. So that is the check here. Okay, next we have to calculate, that is L minimum is obtained and it is checked with the limit. And the next step, we have to calculate B1 and B2. By calculating B1 and B2, our design part is over. So for calculating B1 and B2, I have told that you have to equate the values of area and values of centroid with the original equation. That is x1 bar is equal to L by 3 into B1 plus 2B2 by B1 plus B2. And substitute these values. x1 bar is 2.82 and L is 6.5, L minimum 6.5 by 3. So equation 1, that is equation 1. And second equation in terms of area. So before that we have to calculate what is the area. Area is equal to total load by QNA. Total load is Q1 plus Q2, that is 3500. QNA is given as 200 kilonewton per meter square. So area is 17.5 meter square. So equation of area is L by 2 into B1 plus B2. So that is equal to 17.5. So we have obtained two equation in terms of B1 and B2. Okay, and by solving this equation 1 and 2, we will get B1 as 3.76 meter and B2 as 1.62 meter. And we can approximate as B1 as 3.8 meter and B2 as 1.65 meter. Okay, so this is the design part. So we have found the dimensions like L, B1 and B2. Okay. So the last step is pressure gradient. Okay, so pressure gradient at the foundation level is total load Q by area, Q by A, that is 3500 divided by area using the obtained dimension, that is L by 2 into B1 plus B2, and pressure gradient at foundation level is obtained as 197.6 kilonewton per meter square. And here the pressure gradient is not uniform. As in our previous rectangular footing, the pressure gradient is same because it is rectangular cross section, but here it is trapezoid. So the pressure gradient at left hand edge will be equal to so here we have to find the pressure intensity, that is pressure gradient into that width B1. Okay, so here it will be B1, that is 197.6 into B1 3.8. So that is the pressure intensity at the left hand edge, that is 750 kilonewton per meter. And at the right hand edge, the pressure intensity will be equal to 197.6 into the B2, that is 1.65, that is 326 kilonewton per meter. So it is like this because at the left hand edge the pressure intensity is higher than that of the right hand edge because here the dimension is somewhat more. So this is the complete design of trapezoidal footing. Okay, so in the trapezoidal footing the design step is like this, that is first equate sigma ma is equal to 0 and get the value of x bar, then calculate x1 bar. Okay, then check whether this x1 bar is in between L by 2 and L by 3. Okay, next to calculate B1 and B2, equate these two equations, that is area and equation of area and equation of centroid, and by solving these two equations we will get B1 and B2. So this is the design, and next if it is asked to draw the pressure gradient, you can plot the pressure gradient. Okay, thank you.